Okay, guys, this is part B of section 7.3. Section 7.3, part B. This is problems 8 through 13. Okay, problem 8 here for me, it says use an appropriate half-angle formula to find the exact value of the expression sine of 7 pi over 8. Now, first of all, I want to point out that 7 pi over 8 equals 7 pi over 4 divided by 2. Okay, so remember that 7 pi over 4 times 1/2. So that's, you'd get back to the 7 pi over 8. So it's 7 pi over 4 that we're going to use. Now, I also want to remind you of the half-angle formula for sine. So our sine half-angle formula, if we have sine of x over 2, this equals plus or minus, remember the plus or minus depends on what quadrant you're in, whether sine would be positive or negative there, 1 minus cosine x divided by 2. The half-angle formula for cosine is 1 plus cosine x divided by 2, and then tangent has two different ones. I went over those in the part A video for 7.3. Okay, so let's use that formula then for the problem we have. So if I use my handy-dandy formula, this is going to give me, now first of all, 7 pi over 8 is in the second quadrant. Okay, so let me also say second quadrant, sine is positive. Okay, so we don't have to worry about the plus minus, it's just going to be plus. So that's the first thing that jumps out at me. So then we are going to have square root of 1 minus cosine of 7 pi over 4 divided by 2. Now, 7 pi over 4 is almost 2 full pi. Okay, 8 pi over 4 would be 2 pi. So it's in the fourth quadrant. Cosine is positive in the fourth quadrant. And of course, anytime you divide by 4 means it's going to be, in radians I should say, it means it's going to be like a 45-degree relative angle. So this is going to give us square root of 1 minus root 2 over 2 all over 2. Now, this gives us square root of 2 minus root 2 over 2. If I combine like terms on the top, I'm not going to go over all the steps of that. I did that many, many times in section 7.1 and 7.2. So it's like we had to multiply this first fraction over here by 2 over 2. So then we could have common denominators and combine them together. So this then is going to give me square root of 2 minus root 2 over 4, okay, which is square root of 2 minus root 2 over 2. Okay, because the square root of 4 on the bottom is just 2. Now, if it doesn't like that, you could try pulling out the 1/2 and make it 1/2 times the square root of 2 minus root 2. And again, I know you've got a root under a root, and that's all right. Nothing else you can do with it. Okay, so either one of those should be fine. So that was problem 8. Okay, moving right along. Problem 9 says evaluate the expression under the given conditions. Now, we have to evaluate. So we are evaluating cosine of 2 theta when it tells us that sine theta is negative 3/5 and theta is in quadrant 3. Okay, so we're back to using double angle formulas, but they give us sine theta. So really, if you remember back on our double angle formulas, we had one that just had sine. Okay, so double angle formulas, let me remind you that cosine of 2 theta, I'm just going to use the one that has sine, so I have to do the least amount of work. It's 1 minus 2 sine squared theta. Okay, that's the formula for cosine of 2 theta. That's one of them. Remember, cosine has 3 different ones, but that's one. Since they already gave us sine theta, that tells us what we need to know. Okay, so all we have to do is poke that in our formula. So cosine of 2 theta is 1 minus 2 times sine squared theta. Well, sine theta is negative 3/5. We are squaring that. Okay. I am just poking that in a calculator, and we get a whopping 7/25. That's your answer. Okay. And quadrant 3, well, we know that sine is negative in quadrant 3, so we already had the negative taken care of here in the negative 3/5. So then we're just using the algebra to come up with cosine. So if theta is in quadrant 3, then twice that is going to more than likely be in quadrant 1, which is where cosine is positive. So that's why we end up with a positive answer. Okay, number 10. That's all there was on number 9. Pretty short. Number 10. It says evaluate the expression given or under the given conditions. So again, we are evaluating sine of theta over 2. So we're going to have to use a half angle formula. Given that tangent of theta is negative 3/4 and that theta is in quadrant 4. Okay, theta is in quadrant 4 and tangent theta is negative 3/4. So if you remember our half angle formula for sine, we have to know cosine. Okay, so I need to kind of draw a picture here. So if we're talking, we're in the 4th quadrant, that's down here. Okay, so this would be my theta. And if tangent is negative 3/4, if you remember, tangent is opposite over adjacent. So this is negative 3, this is 4, my hypotenuse would be 5. It's a 3, 4, 5 triangle. So that means then that cosine theta is going to be, if you remember, cosine is adjacent over hypotenuse, is going to be 4/5. Okay, and it's going to be positive in the 4th, or yes, in the 4th quadrant. Now, something else, we got to know the formula for the half angle of sine. If you remember the formula for half angle of sine, sine of theta over 2 is plus minus 1 minus cosine theta divided by 2. So plus or minus the square root of 1 minus cosine theta divided by 2. Now, if theta is in quadrant 4, then that means that half of that angle is going to be in quadrant 2, which means sine should be positive. Okay? Half of an angle that falls in the 4th quadrant should give you something in the 2nd quadrant. And sine is positive there. So I only have to deal with the plus part of this. So sine of theta over 2 would be again, the positive square root of 1 minus 4/5 divided by 2. Okay? Because again, cosine theta is 4/5, and minus was part of the formula in the numerator there. So this is square root of 1/5 divided by 2, which is the square root of 1/10. 1/5 divided by 2 is 1/5 times 1/2. Okay, so this is square root of 1 over square root of 10, which is 1 over root 10. I don't know why I'm taking this to the extreme here. Then to rationalize the denominator, again, we would have to multiply top and bottom by a root 10. So you would end up with root 10 over 10. That would be your answer. Okay. Now, next one. Problem 11, we are proving the identity. So here's the identity. 2 times tangent x over 1 plus tangent squared x equals sine of 2x. Now, this takes us back to like what we had to do back in 7.1. This is where they just have a big box and they tell you to show your work. So you need to type this out the best you can. Okay. Once again, we are going to be manipulating the left side. Okay, I'm going to be replacing the tangents with sine over cosine and then doing some algebra, some basic math functions on them to get them to look like sine of 2x. Now, instead of looking like sine of 2x, we're actually going to get it to be the formula for sine of 2x. Let's remind ourselves one more time. The formula, the double angle formula for sine. Sine of 2x equals 2 times sine x cosine x. Okay, that's our formula. So I'm manipulating the left-hand side here. So I've got 2 times sine x over cosine x, that's what tangent equals, all over 1 plus sine squared x over cosine squared x. Now, on the bottom, I need common denominators. So again, I'm going to have to multiply this 1 by a cosine squared x over cosine squared x. Okay, so on top, I have 2 sine x over cosine x all over cosine squared x plus sine squared x over cosine squared x. Now remember, big fat fraction bar means you're dividing. Okay, so this is 2 times sine x over cosine x times cosine squared x over cosine squared x plus sine squared x. Now, cosine squared x plus sine squared x, one more time, is the trig identity, and that just equals a 1, right? So I'm just going to mark through it. It just equals a 1. That's the trig identity. Now, a cosine, you notice, will cancel. One of these cosines will cancel with one of those on top. So all I am left with then is 2 times sine x times cosine x. Well, look at my formula I put in the blue box up there. What is 2 times cosine x, or 2 times sine x times cosine x equals? That equals sine of 2x. Those are my steps. That's what I would have to show in my box. Again, myself and Jim Patrick will be looking at these freehand ones that you have to type in the box. Okay? Now, the last two, 12 and 13, are just kind of fill in the blank ones. Okay? But I'm probably going to put more steps on the board than they have fill in the blank. So hang with me, because I think they kind of jumped some steps. So I'm going to put more up there. So make sure you're looking at the right step to figure out what the fill-in part is. Okay? So number 12, we have prove the identity. 4 times sine of 4x all over sine x equals 16 times cosine x times cosine 2x. Yuck. Okay, now, first of all, we're going to have to use, once again, the double angle formula for sine. Okay, so let me write it up one more time. So sine of 2x, you remember these? Sine of 2x, we've written this so much now. It's 2 times sine x times cosine x. Now, we're going to have to do this a couple of times because we have a sine of 4x. So the first time we apply the formula, we're going to drop from a 4x to a 2x. Then we're going to have to apply the formula again to drop from a 2x to a 1x. Okay? So let's substitute in here. So this is going to equal, again, I'm just manipulating the left-hand side right now. Okay, just manipulating the left-hand side. So this is 4, and this is an extra step than what the book has, because I don't like, they kind of left this one out. So here's my 4. Okay, here's where the 4 came from. So 4 times my sine of 4x, I'm rewriting as 2 times sine of 2x times cosine of 2x. Okay. And all of this, of course, is still over sine x. Now, that's my first step. So then this gives me, I'm just multiplying the 4 and the 2 together. This is the first step in your homework. So 8 times sine of 2x times cosine of 2x all over sine x. Now, we are going to use the formula again on the sine of 2x. We're going to leave the cosine 2x alone because there's a cosine 2x on my right-hand side of my equation. Okay, so we're going to leave that one alone. So I have used the formula once. Okay, I used it once for here, and now I'm going to use it again and put it in place of here. So this is going to give me 8 times 2 sine x cosine x, and then I've still got the cosine of 2x all over sine x. Now, what do you notice? A couple of things here. First of all, my sine x's on top and bottom will cancel. And then this leaves me with 16 cosine x times cosine 2x. Okay, that's where the 16 comes from. All right, so in your homework, at least if you have the same problem I do, this part right here is one of the blanks, okay? And this part right here is another one of the blanks. And then, of course, your last step, this is one of the blanks. Okay, last problem. Hallelujah, praise the Lord. Number 13, prove the identity. Okay. Prove the identity. Here we go. Again, they kind of leave a few steps out, so hang with me. I may have more steps than they do, but my problem is 36 cosine to the 4th x minus 36 sine to the 4th x equals 36 cosine of 2x. Now, Here's what I want to point out. This left-hand side is the difference of two squares. Difference of two squares. If you remember the difference of two squares formula, it says that if you have a squared minus b squared, it equals a minus b times a plus b. That's what the formula tells you. Okay, difference of two squares. My writing leaves a little to be desired there. So what I'm actually kind of doing here is coming in here and taking the square root of both sides, okay, to get my a and my b. So difference of two squares formula. This is going to leave me with 6 cosine squared x minus 6 sine squared x times 6 cosine squared x plus 6 sine squared x. Okay, again, take the square root of both sides. Square root of 36 is 6. Square root of cosine to the 4th is cosine squared. Okay, so one of my binomials has a minus, one of them has a plus. That's the first step. Now, that's the difference of two squares formula. Now what I'm going to do is on the plus one over here, this one right here, I can factor out a 6, and I'm left with cosine squared x plus sine squared x. Well, what does cosine squared x plus sine squared x equal? Once again, that's one of our trig functions. This equals 1. Okay, so now what I'm left with is 6 cosine squared x minus 6 sine squared x times 6. Okay, 6 times 1 is just 6. Now, I can also pull a 6 out of the first two terms, right? So if I pull a 6 out of the first two terms, then this becomes 36 cosine squared x minus sine squared x. Okay, factored the 6 out of the set of parentheses and combined it with the 6 behind. 6 times 6 is 36. Now, cosine squared x minus sine squared x. If you remember, okay, one of our double angle formulas for cosine of 2x, okay, remember cosine of 2x had 3 formulas. One of them was cosine squared x minus sine squared x. That's one of our double angle formulas. So we're going to substitute in here cosine of 2x. So this gives me 36 times cosine of 2x. There we go. Now, this concludes section 7.3 completely. This is the end of 7.3 part B.